life is too short to work at a crappy company. That's why Software Engineering Daily is proud to be sponsored by Hired.com, the job marketplace for software engineers. If you accept a job through Hired, they will give you a $2,000 bonus. But as an extra bonus to our listeners, you can get an additional $2,000. That's $4,000 total if you sign up by going to softwareengineeringdaily.com and using the link on the right side of the page to sign up. Hired.com will set you up with 5 great companies for interviews. These are companies like Stripe, Facebook, Uber, companies you would actually want to work for, where you can go and learn the cutting edge of software engineering. Go to softwareengineeringdaily.com, click on the banner on the right, and try out Hired.com. Jon Sneyers is one of the developers behind the free Lossless Image Format, or FLIF. Jon, welcome to Software Engineering Daily.
Hi.
So this episode is about an image format, FLIF, or free lossless image format. And this may sound like a niche topic that does not impact the general programmer, but I think that the advances and the trade-offs of different image formats reflect many broader trends in software development. Jon, why is image compression so important?
Well, for starters, an average website, according to some statistics I read somewhere, an average website contains approximately 60 or 65% of the contents are images, if you look at it in terms of bandwidth. So if you want to have a fast-loading website, image compression is, well, probably the most important thing that is going to speed up the website. Another thing is, in general, not just websites, there is this tendency to have displays and, screens, televisions with higher and higher resolutions, right? So full HD is basically the lower bound, more or less, at this point. We have 4K screens and so on. But if you actually want to transmit all of those pixels or store all of those pixels in an efficient way, you're going to need image compression, or else the bandwidths and the storage media are simply not going to cut it.
Our storage capacity has been increasing over the years, and so image storage represents less of a burden than it did in the past. Mm-hmm. And there's a number of different image formats that I see: PNG, JPEG. Could you give a brief overview of the common image formats?
So I guess on the web, the most frequently used are JPEG and PNG. And also, I guess, GIF, mostly for animated images. So basically, JPEG is a lossy format, so it's not lossless. It destroys some of the information in the image. But the main advantage is that it gives very small files. It can give very small files. It's very suitable for photographs. However, if you would use it for things like screenshots or images with text or sharp edges or line art or things like that, the compression artifacts can be pretty visible, even to a human eye. So, yes, it's not very suitable for those. Then there's PNG, which is quite suitable for things like line art, and it's also a lossless format, so just like FLIF. But the files tend to be quite big, so it's not that frequently used. It is, however, used when you need transparency. So if you need the alpha channel of the image, which allows the background to be seen through the image, then PNG is pretty much the only one out of the three main formats that can do transparency in a good way. And then there's GIF or GIF or however you want to call it, which is the oldest, I guess, of the three. It dates back to the 80s. And basically in all aspects it's worse than PNG, except that it can do animation, which PNG cannot do. So, well, it's currently still widely used for animations.
Yeah. So you've given some of the trade-offs of these different image formats. Now let's talk about FLIF, which is the image format that you're working on. What is FLIF?
What is FLIF? It's an image format. It is designed to be, well, at least the claim I'm making is that it is better than all of the other image formats in terms of lossless compression. In terms of lossy compression, of course, it's harder to evaluate what it means to be the best. But in terms of lossless compression, it produces smaller files, at least on average, than any of the other formats that are in current use. So not just PNG, but also Google's WebP in lossless mode, or the new BPG format in lossless mode. So for each of these existing formats, if you would use FLIF instead, it should, well, not on every particular file, but on average, it should be producing smaller files.
So we'll get into the technicals of FLIF and the algorithmic magic behind it that makes it, that sort of satisfies your claim as to it being more efficient or more powerful. But I want to give a little more context to the broader picture of how images are being used, particularly on the web. In the early days of the web, images were a killer feature. I think I remember hearing a quote from somebody like Tim O'Reilly or Mark Andreessen saying that, you know, when they put images on the web, it made it so much more appealing to the average person. And it's easy to take that for granted, but an all text web is much worse than a web with images. And I'm already thinking about your 60% or 65% statistic of images taking up the content of a page. But the thing is that many of the people who are coming online in the next decade will be in these low bandwidth situations that will feel a lot like the early web, and will have certain constraints placed on image loading and general browser experience. You think of browsing experiences like internet.org that focus on this low bandwidth situation. And so in many cases, these services, these sub-internets are only sending text. I think there's also a version of Wikipedia that serves just very lightweight text versions of Wikipedia. And so I guess, to help bring this into context, does improved image compression help bring this killer feature of images to the developing world faster?
Well, yes, I think so. Well, the main important thing is there's this whole topic of web design, which is called responsive web design, which means that you want to have websites that work well on all kinds of devices in all kinds of circumstances. So it should work on a desktop PC or on a television, but also on a smartphone or a tablet. It should work if you have a good internet connection, but also if you are in a very low bandwidth situation. So in the context of responsive web design, the current practice basically is to make different variants of your website. So one, for instance, one big version of the website where the images have high quality, high resolution, and so on. And then smaller versions of the website where the images have a reduced quality, have a reduced resolution, or are simply omitted or are cropped or something like that. So that's the current state of the art. And in practice, this means that for each image on the website, you're basically going to create a lot of variants of the image. You are going to transcode it into different files, each representing a different situation to view the website. So, as a simple example, a very common practice is to have thumbnail versions of pictures that just give you a very rough preview of the image, and when you click on it or something, you get the full image, which takes much longer to load if you have limited bandwidth, but which is of much higher quality. Now, of course, it's this solution works, but it requires the server side to have multiple variants of the same image, and it also requires the client to download multiple versions. Well, the idea is that the client should only load the variants that he or she wants to see, but in practice, you typically are going to load more than one variant of the same image, simply because, well, you might be rescaling zooming in or out on the page. You might, well, look at it in different contexts. And so you still end up loading the same data multiple times, which kind of defeats the purpose of getting it there quickly. So I think in this area, FLIF can be an improvement because it has this property, which is not a new property. It already exists in other formats, but it can load images progressively, which means that basically the first part of the file already gives you a rough preview of the entire image. So you don't need to download, say, 5 megabytes worth of a photograph file. You can just download the first 50 kilobytes or something, and you already get a decent preview of the entire image.
I find this trade-off very practical, and I want to get more into those technicalities. But let's start with a technical discussion of just compression in general. FLIF or FLIF or free lossless image format outperforms the PNG and JPEG file formats in terms of compression ratio. What is compression ratio?
Okay, so first of all, it's a bit hard to say that it outperforms JPEG because JPEG is not lossless. So
that's true. Okay.
So in general, JPEG files will still be smaller than FLIF files for the same image, but they will not represent the full information that is present in the image. So they will basically try to eliminate some information and hope that you don't see it, that this information is getting lost. But anyway, so what is the compression ratio? The compression ratio is basically the proportion, the size of the compressed image compared to the size of the uncompressed image. So basically an image is a collection of pixels. Each pixel has takes a number of bits to encode. So if you have, the typical scenario is that you have RGB pixels, maybe with transparency. And so this would take 3 or 4 bytes per pixel if you have 8-bit of color depth. So the uncompressed image would basically just take 3 or 4 bytes multiplied by the number of pixels. So if you have a 5 megapixel picture, just 5 mega, which is 5 million times 3, because photographs don't have an alpha channel in general, typically. So it would be 15 megabytes, give or take. So 15 megabytes for one picture is quite a lot in most circumstances. So you want to compress this. And then you can compress it losslessly or lossy. So most low-end cameras will compress it lossy, right? So they will produce a JPEG file, which eliminates some information and which compresses the remaining information into a file which has a lower size. The high-end cameras will typically produce raw camera files which contain losslessly compressed picture information. So they take all of the information that is present in the image and try to represent it in a more concise way, so producing a smaller file than just the uncompressed image.
Okay, so let me ask a different question around the engineering. If I'm a user on a smartphone and I pull up a web page with lots of FLIF images on it, does my phone decompress the images, or are they decompressed on the server before being sent to me?
So the phone does the decompression. So the idea is that on the server side, the images are sent in compressed form, so that the amount of bandwidth needed to transfer the bits to your phone is reduced. So if the server would have done the decompression already, then it would be a lot of bits to transfer to the phone. So it's always on the client side that the decoding needs to happen.
Right. So the client always receives a compressed image, so an FLIF compressed image. And let's talk more about the progressive decoding use case, like the case where a user doesn't have an optimal bandwidth situation. You already mentioned this earlier, but I think it's worth driving home. Can you talk a little bit more about progressive decoding? What is progressive decoding, and how does the progressive decoding for FLIF differ from that of other image formats?
Right. So the other image formats also have this feature, but it's not particularly widely used in practice. So also JPEG has a progressive mode, PNG has an interlaced mode, which is the same thing basically. So the idea is that the most important image information is stored in the beginning of the file. So if you load just the beginning of the file, you already get a rough but quite good preview of the image, and then the details are filled in later when the rest of the file is getting loaded. So this is a strategy that was even already used in GIF, because of course in the early 90s when GIF images were very popular, the bandwidth situation was also not very good. So GIF also had this interlaced mode, which meant that you could get a preview of the entire image before it was completely loaded. Now the difference technically between the way FLIF does it and the other formats that do it is a bit tricky to explain, but I think the end result is that you get a decent looking image faster than with the other formats, because the interlacing mechanism is a bit more advanced. Also, in the other formats like PNG and GIF, the problem is that if you want to be able to progressively decode the image, you have to encode it in a special progressive mode, interlaced mode, and the end result is that your files tend to get bigger than if you would just compress them in the normal mode, the non-progressive mode. So PNG files, for instance, if you interlace them, they tend to be 20 or 25% bigger than they would have been if you wouldn't have saved them in the progressive mode. So you have to make this trade-off. Do I want to make them load quickly, get a quick preview, but in the end the user has to download more bytes? Or do I just encode them non-progressively, so the total file size is limited, but the disadvantage is that you cannot get the early previews. So in this respect, I think, FLIF also has this property that the progressive files tend to be bigger than the non-progressive files, but the difference is much, much less pronounced. It's only a matter of a few percent. So the default encoding mode in FLIF is to be progressive for this reason, because basically the overhead of making it progressive is small enough to be, you can ignore it in practice.
We'd like to take a moment to thank our sponsor. DigitalOcean offers simple cloud infrastructure for developers. In one click, you can have a mean stack, a Rails application, an Ubuntu box, or another custom environment. Software Engineering Daily is proud to have DigitalOcean as a sponsor because DigitalOcean is the simplest cloud service provider. I've interviewed Moisey Aretsky, who is a founder of DigitalOcean, and he told me that DigitalOcean was based on this realization that other cloud service providers are so complicated. If you want things to be simple when you deploy your application, use DigitalOcean. To try DigitalOcean, go to digitalocean.com and enter promo code SEDaily. That promo code is one word, SEDaily. Now let's get back to our show. FLIF relies on maniac compression. Mm-hmm. What is maniac compression?
Maniac is just a backronym we invented because it sounded nice. It's a meta-adaptive near zero integer arithmetic coding. So it's a variant of arithmetic coding, which is, we call it meta-adaptive because basically the context model itself is adapting to the particular image you're encoding. And this is a more or less novel technique, I think.
Yeah, and the FLIF documentation mentions this. It mentions that maniac compression creates decision trees at encode time, mm-hmm. and that leads to an image-specific context model. Can you describe this process in more detail?
Yes. Well, so basically when encoding a file into FLIF, what is happening first is that it is getting kind of mock encoded. So we're acting as if we're going to encode it, but we're not actually writing any bytes to the disk. A couple of times, so by default 3 times. And while we're doing this mock encoding, we're basically learning properties about the image so we're growing trees, decision trees, during this encoding. And then when the real encoding starts, first we output the trees to the file, so the decoder can get these trees, and then they are used during the real encoding. And these trees make sure that the context model of the arithmetic coding is adapted to the actual image. So that's more or less the idea.
Right. And so I think it's worth pointing out, like, can you apply maniac compression to all sorts of files? Like, would you want to use maniac compression in place of zip or tar?
Well, that would be an interesting generalization of the approach. So currently, these decision trees in their decision nodes, they test properties that are kind of specific to images. So it's properties of the kind, what is the difference between the value of the pixel to my left and the pixel above, or something like this. So these properties are defined in terms of images, but the approach in general is generic. These properties could be other things as well. So yes, I think it would be possible to create a maniac encoder for other things like text files or something like that, or maybe audio or whatever. But then you would have to define relevant properties for these kinds of media. So you could also make a very general compression scheme, but then you would have to invent properties that are sufficiently general to be useful on arbitrary data. But the general idea of learning these decision trees is something that probably would work well for other types of data as well.
Very interesting. Have you done any speed benchmarks for how long it takes to compress and decompress files using Maniac?
Well, obviously, when I'm doing the benchmarks, it's as a side effect, I also get some speed information. Now, this is a prototype implementation, so it's not very optimized. And this means that, well, if you look at the other image formats like PNG or JPEG, they are old, mature formats that are well implemented, well optimized, and in many cases they are kind of hardware accelerated, or they have very optimized implementations in assembler languages and so on. So this prototype I currently have is not yet optimized to that extent. So it will have a kind of speed disadvantage because of that. It also, of course, has a speed disadvantage because the compression techniques are inherently more complicated. So it will take more CPU power to do the encoding and decoding. However, if you look at the current prototype, it's in terms of compression speed, it's worse than PNG, but not that much worse. And it's certainly much better than if you would optimize PNGs in a kind of brute force way, like with something like PNG Crush or OptiPNG or Zopfli PNG or tools like that try to create the smallest possible PNG file. Well, those tools, they can take a long time on a single file, and FLIF will be much faster than those. So it's I don't think speed will really be the main issue, because CPU power is getting, CPUs are faster. They have plenty of cores to do these kind of tasks, even on a mobile phone. And the main limiting factor is bandwidth, even memory bandwidth. So I don't think that speed will be a very big issue, but of course there will be applications where you have limited CPU power, and then some of the simpler formats will be more suitable.
Did you discover Maniac compression? Or create it?
Yes.
Okay, that's what I thought. How did you discover the algorithm? How did you think it up?
Well, it was not just me. It was in collaboration with Peter Welle, who is an ex-colleague of mine at the University of Leuven. And basically, it was a kind of side project we did. We talked about it during coffee breaks and we brainstormed. And I don't remember exactly how we came up with it. Because it's a project I think we started already in 2010, thinking about this. And only recently I've been putting some more time in it to create a very to create a prototype that actually works, right? But the main ideas of the maniac trees, they date back a couple of years already. Yeah.
Interesting. So you've talked some about responsive imaging. I'd like to discuss this a little bit more. What are the important differences between serving an image to a phone and serving an image to like a web browser on a laptop?
So if you have a limited bandwidth and also a display device that maybe has a very large resolution, because phones nowadays have lots of pixels, but the image, the screen itself is going to be small. So, well, maybe the fine details don't really matter that much. Maybe users will not be able to see the fine detail anyway. So if you have this situation of low bandwidth and limited resolution or limited area of screens, then it doesn't make sense to load a highly detailed large resolution image, because it would make your browsing experience not very satisfactory. It would be kind of slow. So what is typically done is low quality versions of the image will be served to the user instead. This can be on the server side. This can also be done sometimes using kind of proxy servers that on the fly transcode the file to a lower quality version of it. So in general, the idea is to create lower quality versions of the file and send those to the user. Now with FLIF, instead of doing that, you could just send them the actual lossless image, but let the client side decide when to stop downloading it. So instead of making different versions at the server side and trying to let the server decide which version of the image should be sent to the user, I think it makes more sense to let the client side, to let the user side decide how much detail he wants to load. So if you just have the single FLIF file and you start downloading it, if you would have, this is still something that needs to be implemented, of course. If you would have an intelligent browser that can decide when to stop downloading, then things would be much better, because then there's a lot of improvements that could be done that would be implied by this. So if there's only one image, then all of the caching services would just have to cache one version of the image instead of all those different ones. So the proxy servers would have a much easier job. Also, if the user decides to download the full quality version of the image, then they already have the first part of this. So they just need to resume the download instead of starting to download a completely new version of the file. So, also, it's the client who knows best what kind of decisions to make. Maybe the user does have a lot of bandwidth, but he's paying per downloaded byte or per downloaded kilobyte. And, in that case, the user might decide to only load small fragments of the file, the small prefixes of the file, instead of loading all of the detail just to save some money.
Yeah. So another processor-intensive image application that I think of is mapping. Like an application like Google Earth or Google Street View. It seems like it would have a lot of issues in developing countries. Would FLIF help with this type of application?
Well, to the extent that actual images are used, it could help. But I guess when you're making maps, you probably want to use a kind of vector representation of the map instead of using pixel images. So FLIF is just for pixel images. It wouldn't help there. And if you would have these street view pictures, then probably you want to do some kind of lossy compression. So FLIF wouldn't really help there either. But, well, in scenarios where you have pictures where lossless compression would be beneficial, then FLIF could help a lot because, yes, this progressive loading would help a lot in low bandwidth situations. So, well, maybe if Google decides to make their street view with very high quality pictures instead of lossy JPEGs, then FLIF would be a good format for that, yes. But I think they would rather use Webp, probably.
What is Webp?
Webp is Google's newest image format. So it both has a lossy and a lossless mode. And it's quite good. It compresses, in the lossless mode, it's probably the main competitor for FLIF. It compresses almost as good as FLIF.
Why don't I see like images that have the Webp file extension on the internet?
That's a good question. Probably mostly because of inertia, and because of people are still using very old technology, because there's this kind of common denominator effect. If you want a website, you want to make sure that everybody can view it. So if you're going to use the newest technology, there's always a segment of viewers that will not be able to view the website well. Now, this, I must say, is mostly a problem of the past, though, because you can more or less assume that browsers are going to be able to understand JavaScript. And once they understand JavaScript, you can basically circumvent the problem of outdated browsers by doing the decoding. If the browser doesn't support it natively, by doing the decoding in JavaScript. And in fact, there is already a JavaScript decoder for FLIF. So essentially, people could already start using it on their websites, and it would work on any browser that does have JavaScript. Now, the only disadvantage of JavaScript is that it has improved a lot. It is more efficient than it was before, but it's still not as efficient as native support, and it probably never will be, because it has to be sandboxed and so on. Yeah.
Can you give a little more color on the differences between Webp and FLIF?
Or
is Webp open source? Or?
Yes, Webp is also open source. It has this Google. I don't know exactly which license or which patent situation, but it is open source. Webp basically. I don't know exactly what techniques Webp uses, but it's based on the same general compression ID as PNG, which is the same as in zip, which is LZ compression. So for some kinds of repetitive patterns, this works very well. So you can construct some images which will be smaller in Webp or PNG than they will be in FLIF. But in general, arithmetic coding is a superior compression technique compared to LZ compression. It's computationally more expensive also, but yeah.
Another file format that I hear a lot about lately is the SVG file format. Could you talk about what an SVG is and why hasn't that been mentioned in the conversation? Why doesn't SVG not qualify as an image format?
Oh, yeah. So SVG is a vector format. So it doesn't represent pixels; it represents vectors. Basically, the image doesn't have a fixed resolution, but it can be rendered at any resolution you want. So it's scalable vector graphics is what the acronym says because of this.
Okay.
So SVG has of course a lot of advantages because of the scalability, because it's also typically very compact, because you're not representing each pixel, you're only representing the actual vector information. But the main disadvantage is that, it works if you are making these drawings yourself and you can record the actual vector that is being drawn. But if you start from an image, for instance, that you take with a camera, then turning that into an SVG is not going to be easy. So, of course, there exists software that tries to construct vectors from the pixels, but this is, in general, this is not really possible. So it only applies for a specific type of line art kind of, or clip art kind of images, but it's not really suitable as a generic image format.
So let's begin to close off. What is on the roadmap for FLIF?
So I think the first things we want to do now is to finalize the decode stream so that the format becomes stable and reliable, and people can start to encode files as FLIF and be sure that in the future it will be possible to actually decode them, because at the moment it's still an experimental file format, which means that, as we are changing the implementation, as we are changing the definition of the format, it means that when you encode a file with the current experimental version, then maybe it will not decode correctly with the one we have next week. So finalizing the definition of the format, the specification of the format, is probably the highest priority right now. And once we have that, we can start looking at ways to optimize the implementation, and we will probably release it as a library so that other projects can start using it and browsers can start supporting it natively.
Great. Well, that makes a lot of sense. Jon Sneyers, thanks for coming on to Software Engineering Daily and talking about FLIF. It's been really interesting.
Thank you. It was my pleasure.